Next, on how does it work? The laptop cooling system. Amazing little pipes that are working hard to take the heat and get rid of it. The laptop computer cooling system. It's often overlooked, and yet it's an essential system. Without it, the amount of heat generated during the computer use could destroy the computer. It's a system that must be both extremely compact and extremely efficient. Everything about it depends on heat pipes, components that take advantage of two things: conduction and changes in the state of water. All this in order to capture heat on the inside and expel it on the outside. But how does it work? The laptop, the motherboard, with microprocessors that generate incredible amounts of heat. A fan, some cooling fins, and connecting the fins to the main heat sources, those heat pipes. They're special copper pathways, both hollow and airtight. Nothing goes in and nothing comes out. When the laptop is working, its components heat up, some reaching over 100 degrees Celsius. Luckily, even though they're airtight, the heat pipes are able to capture heat at one end and transfer it all the way to the other end. Essentially, they get rid of the heat by transferring it to the fins. The fan circulates air, which absorbs all this heat, and then it's blown outside. But to understand how airtight pipes can capture, transport, and get rid of heat, let's take it apart. The heat pipes are in contact with the laptop components that generate all the heat. They're right below them, and even though the pipes are hollow, they're not empty. Copper filaments line the pipe's cavity, and in between them is pure water in liquid form. Now, when two objects physically touch each other, heat is spontaneously transferred from hot to cold. That's conduction. So when the laptop's components heat up, the surface of the heat pipe absorbs the heat through conduction. Inside the cavity of the heat pipe, the temperature climbs, and the liquid water between the filaments starts to absorb the heat. It evaporates. It changes state. This hot water vapor fills the cavity of the heat pipe surrounding the filaments. And so begins a cycle that lets the heat pipe transfer the heat outside. At the other end, the sides of the heat pipe are cool because they're in contact with the fins, which are being constantly cooled by circulating air. The sides of the pipe absorb the heat of the water vapor. As it loses its heat, the water changes state again. It reverts to its liquid form and begins to collect between the copper filaments. Gradually, it fills the spaces between the filaments until it reaches the hot end of the heat pipe, where it evaporates once again. In the copper filaments, the heat-laden water that evaporates is constantly replaced by cool water, so the cycle continues. The heat transferred from the microprocessors to the pipes at one end and from the pipes to the cooling fins at the other is all thanks to the beauty of conduction. And the movement of the heat between the two ends of the pipe is only made possible by the changing states of water inside the heat pipes. That's how the heat is captured, moved, and expelled. The laptop computer cooling system. It's small-scale, ingenious, and efficient. Thanks to heat pipes, which have mastered conduction and changes in the state of water, laptop computers can be overworked without overheating. Coming up on How Does It Work? The chain hoist. All it needs is 2 chains and a set of gears to concentrate one man's pulling power into superhuman lifting power. And the flexible rotary power tool.